Okay, so now we're going to talk about simplifying rational expressions. And remembering that rational expressions are really just fancy-looking fractions. We have to remember all of the fraction stuff. So remember, when fractions, and we're simplifying fractions, we reduce when we see the same thing on the top and on the bottom when it is in factored form. So of course the key here is that everything has to be factored, and that once you've got it in there, you can once you've got it in the factored form, you can do some reducing. Now I'm going to do an example using a regular fraction. So let's do 15 over 25. Now we can see that this is easily simplified, but I'm going to do it using prime factorizations because I want you to see the 3 times 5, and of course this is 5 times 5, and then these are in factored form. That means that it's all multiplication and division, right? There's no adding or subtracting here. So when I see that it's in factored form, that's when I can go ahead and say, all right, 5 over 5, that's 1, and then what's left over is 3/5, and I have simplified that. Let's go ahead and look at something like 2 sevenths plus 3 sevenths, and we know that when we add fractions, we have 2 plus 3. We add the numerators, and we just keep that denominator. Now let's say we had something like this. Let's do 2 sixths plus 1 sixth. And we go ahead and we do our 2 plus 1 over 6. Now in this case, we know that what we would do automatically is we would just add the 2 plus 1. What we would not do is try to simplify here. If we did, we would end up with 1 plus 1 over 2 and over 3, and we would get 2/3. And what we really, if we were doing this correctly, and of course remember this is wrong, if we did this correctly, we would take 2 plus 1 over 6, and then instead of trying to simplify it like we did here that was wrong, we would just add those numerators and then simplify, and we would have 1/2. So of course we can see very clearly that 2/3 is not 1/2. So this is not something that we can do. You can't simplify. Now what tells us that we can't simplify? What tells us we can't simplify is that there is a plus or a minus in that numerator. As soon as you see there's a plus or a minus in the numerator, you know that you have to do something else. All right, it's got to be factors, or it's not, or you can't simplify it. So let's take a look at the problem that we did earlier, and I actually already started us on this, and we said x minus 3. I suggested that you put that into a parentheses just to make sure you remember to keep it together, and then we had this in factored form, x plus 4, x minus 3, and then we look for anything that's the same top and bottom, and we see that we've got x minus 3 over x minus 3. So these are two factors that are exactly the same. Now, the numerator doesn't just get to disappear now. If you have canceled everything out of the numerator, what we need to remember to do is put that 1 in. So after we have simplified, getting rid of that x minus 3, we're left with a 1 in the numerator. I forgot my 4 there. And an x plus 4 in the denominator. And that is in its most simplified form. We've got to remember this, that if everything reduces out of the numerator, there's still that 1. So keep that in your head. That is one of the common errors, believe it or not, when people start working on this. We start focusing a little too much on the polynomials and forgetting sort of some of the basic fraction rules. So let's do a few examples. And again, when we see that we've got these polynomial rational expressions, the first step is to factor if we can. Now the numerator is a sum and difference of perfect squares. So we have the square root in the first position, the square root of a squared, of course, is a, square root of the second is b. Now I'm going to spend less and less time describing how we do factoring, because the point of this, of course, is to simplify a rational expression. And now we have this a minus b in the denominator. Again, I'm going to just put that in parentheses so I remember that it has to go together. Then I see if I've got anything the same top and bottom. I see I've got a minus b in the numerator and in the denominator. Now there is a 1, an automatic 1 in that denominator, but of course we don't need it because it's in the denominator, because that is the same as that. So let's do this next one. Again, factor if you can. So the numerator has a 3 greatest common factor. That gives me a 4m squared minus 1. It has a 4 greatest common factor, and that's 2m minus 1. Now we see here that that's the difference of squares, so we can factor that again. So the difference of perfect squares, so that is the square root of the first term, the square root of the second term, plus, minus, and bring our denominator with us because neither one of those factors can be factored any further. We look to see if we've got anything the same in the denominator and the numerator, and we do. We've got 2m minus 1. And so what's left over is in the numerator 3 times 2m plus 1, and the 4 in the denominator. One of the common questions that I get asked here is, do I multiply this back? Do I distribute that back in? And the answer is no, just leave it alone. You don't have to do any more work once you've got the anything simplified out that you have to simplify out. So here's a couple more problems. Again, this might be one of those places where you want to pause and start again. I'm probably not going to have another video on this particular activity, so you may want to pause and try these. So remember, of course, the first thing you're going to do is factor, then you're going to look for anything that's the same top and bottom, and then you are going to simplify anything that you can. So let's see, we see that these are both 4-term polynomials. So one of the things that you have to realize you're going to do, you may have to rewrite things because it's really hard to do a 4-term polynomial just sitting like that. So we're just going to rewrite the numerator. And we know that when we have a 4-term polynomial, we just have to split it up. We look for a greatest common factor in the numerator, in the first 2 terms. So that's z, and we divide that out. We're left with w plus 4. Bring down that middle sign. Greatest common factor in the next set of terms is 3. So we divide the negative 3 out, and we're left with w plus 4. Our new greatest common factor is w plus 4. When we divide that out, it's z minus 3. So now we go back up here, and we've got this in factored form. And now we're going to go ahead and factor the denominator. Again, I'm doing it off to the side because we just have to do that sometimes. 4-term polynomial, we know we split it. Greatest common factor in the first 2 terms is z. Divide it out. Keep that sign. Greatest common factor in the second 2 terms. Divide it out. Now in our new polynomial here, we see that we've got w plus 4. And when we divide that out, we've got z plus 5. And now we can go ahead and put this back up here in the denominator position where it belongs. And you'll notice that I'm keeping everything in parentheses nice and tidy like we should. We see if there's anything that we can simplify. And we have a w plus 4 and a w plus 4. That leaves us with z minus 3 over z plus 5. And of course, we need to be done now because we've got these pluses and minuses between the z and the constant term. So that means that it's not simplifiable, and if you need to, put it in parentheses to remind yourself, that's fine. I'd rather see the parentheses than have you try to simplify this when it can't be simplified. All right, let's do this next one, and here we see that we've got a greatest common factor of 3m. When we divide that out of the first term, we're left with m. We divide it out of the second term, we're left with 1. Again, we look at the denominator. Greatest common factor is 5. When we divide that out of the first term, we're left with m. We divide it out of the second term, we're left with 1. Now we look to see whatever we can simplify, what's the same top and bottom. So we see the m minus 1, and then the simplified form is whatever is left over. So let's go ahead and simplify, or excuse me, factor the numerator. And that is the difference of perfect squares. So we just do the square root, plus minus. And then we've got this 1 minus m going on. Now what's going on here is, this is going back to that idea of opposites. Now I'm going to rewrite this. We see that we like to have that variable first, so I'm going to rewrite the denominator. So the variable is first. So we get negative m plus 1. Still doesn't look the same. So now I see I've got a negative out here, so I'm going to factor that negative 1 out. Again, I'm taking the numerator with me. Nobody likes to do this. Everybody wants to just do it all in one step, but never a good plan. So now I've got a negative 1, and when I factor negative 1 out of the negative m, I get positive m. And when I factor the negative 1 out of positive 1, I get negative 1. And now I look at this to see if I've got anything the same top and bottom. And I see that I've got m minus 1. Now that leaves me with m plus 1 over negative 1. Again, I'm going to suggest keeping that negative, those parentheses there. And now I've got a negative 1. That's really the same as saying I've just got one negative, because I could rewrite that to have negative m plus 1 over 1. And I know that when 1 is on the in the denominator, I don't need it. So that simplifies. I'm taking every single step I can take here. I don't expect you to take all these, but I want you to understand why this happens. Negative out front, m plus 1, and there it is. Now, the next one is similar to that. And again, you can see that you've got, in this case, the same terms, but they have different signs. So again, taking a longer root here, I'm just going to do negative t plus 6 over t minus 6. I've got that negative out front, so I'm going to factor it out. So I've got negative, I'll even put the 1 there if you like that. And that's going to give me a positive t and a negative 6. And of course, I'm just bringing my denominator with t minus 6. And I see what's the same top and bottom. So I've got t minus 6 over t minus 6. And that leaves me with negative 1. So that simplifies out really pretty. Now our next little rational expression, the numerator is the difference of perfect squares. So I'm going to do this pretty quickly. The denominator is the difference of perfect cubes. So I'm going to say how we factor this, but again, this is with you doing lots of practice to get good at it. So we take the cube root of the first term, keep the sign, cube root of the second term. Then we don't look at this anymore, and we say the square of the first term, change the sign, multiply the 2, so it's 10 times p. The second sign is always a plus, and then 10 squared is 100. And now they're both in perfectly factored form. So we look for anything the same top and bottom. So we see that we've got a p minus 10. So that leaves me with p plus 10 in the numerator, and p squared plus 10p plus 100 in the denominator. And we need to remember, of course, that at this point we can't simplify this because we've got all these pluses in there, And you may again want to put these in parentheses so you remember that they can't be separated. They can't be simplified using the same method as we simplify using factors. So let's just do a couple more. This top one we see, and remember you may want to pause so you can try them real quick. The top one can be factored. There's a greatest common factor, so we pull it out. So we're left with x plus 2. The denominator is a trinomial with a leading coefficient of 1, so we know we just have a double parentheses. And we know the first position is x and x. And then we're looking for factors of 6 that subtract to 1, so of course that's 3 and 2. The signs, that negative tells us the signs are different, and this negative, the negative in the first position, tells us that the bigger product is negative. So that's the negative, that's the positive. We look to see if we've got any factors the same top and bottom, and we see that we do. We have an x plus 2 and an x plus 2. Whatever's left over is the simplified version of our rational expression. So we'll do our next one. And again, we're just going to factor the numerator. It is a trinomial with a leading coefficient of 1. So that's just a and a. The factors of 21 that add to 10, 7 and 3. Signs are the same, both negative. And now we'll factor the denominator. Again, trinomial with a leading coefficient of 1. So that's, again, a and a. And then we go to the factors of 28 that add to 11. So again, 7 and 4. And again, that plus in the in the second position tells us the signs are the same, and the negative in the first position here, in the second position, and the negative in the first position tells us the signs are both negative. So there we go. And then we look to see if we've got anything the same in the numerator and the denominator. We see a minus 7, and we're left with a minus 3 over a minus 4. Again, if you feel like you want to try to simplify more, put these in parentheses to emphasize the fact that you can't.